So, with Delta Math, you looked at doing composition of functions with the equations and also with the graphs. One thing that was not on that Delta Math, because it's not available on Delta Math, is looking at composition of functions with tables. So, it's very similar to like you would do with the graph, but if we're finding f of g of 4, the first thing you have to do is find g of 4. Need a pencil. Okay, got one. So, g of 4, it tells us g is on the bottom line. Our x values are up here, so whatever number is plugged in right here, that is your x value that you're looking at. So, we're looking at where x equals 4. At x equals 4, g equals 1. So, we would now be trying to find f of 1. And so, we would go up here to 1 on our table, and f of 1 is 1. So that would be our answer. Okay, on example 2, we're finding g of f of 3, which means we've got to find f of 3 first. So if you look at that table, what is f of 3? Good. 1, we're looking right there. We see that f of 3 equals 1. That leaves us having to find g of 1. Reese, what do we get for that? Good. And 4 would be our answer there. Okay. Any questions on that? Pretty straightforward, a lot like the graphs. It's just be careful, don't get mixed up with the numbers. Alright. Okay, so here is another opportunity for us to practice what I was just talking about with the square, double square, because we're finding f of t plus 2. So our g of x sort of here, our equation we're plugging in is t plus 2. So if we're finding f of t plus 2, we would take t plus 2 and we're going to put it everywhere that we see an x. Make sure you put it in parentheses. So you got t plus 2 squared minus 4 times t plus 2. Now again, if you need to, over here to the side, you can write out t plus 2 times t plus 2. And you can distribute there and figure that out over to the side if you need to. But even better is you can try to start square, double, square. So you square the first, which is your t, so that just gives you t squared. Double, you're going to multiply the 2 together. T times 2 is 2t. And double it, so you multiply it by 2, which is going to give you 4. And then square the last, which will give you 4. So t plus 2 squared is going to be t squared plus 4t plus 4. And then you just need to distribute that negative 4 over here. And so t squared. Here our 4t's actually cancel out. And we're going to get t squared minus 4. Okay, questions? All right, so, okay, good. Well, I had skipped something I need to show you. All right, so, if we have a function like we see here, we're supposed to find f of g of x and g of f of x. So, for this first one, we are plugging g into f. So I've got 2 times x plus 4 squared minus 7. What do I have to do first here? I got to square it. I cannot distribute that 2. A lot of students want to distribute the 2 first. You can't do that first. Exponents have to come first. So the 2 is going to stay out front. We're going to keep some parentheses. Here's another chance to practice that square, double, square. So square the x. Double means we're going to have x times 4 and double it, which will give us 8x. And then square the last number. 4 squared is 16. Okay, then we'll just distribute here, so we'll get 2x squared plus 16x plus 32 minus 7, so that gives us 2x squared plus 16x plus 25. Okay, questions? All right, when we're finding g of f of x, we're taking f and plugging it into g, so that's going to look like this. 2x minus 7 plus 4 squared. And so you could go ahead and square this like it is, but it will be much easier if you just combine the things that are inside the parentheses first. So I put parentheses around this because I told you that you always should, but there's no number in front of it to distribute. So you can really just combine that negative 7 and 4. So you're going to get 2x minus 3 squared. So again, you could write this twice, but I don't want us to. Caitlin, what's that going to be when we square it out? If we square, double, square. Very good. 2x squared is 4x squared. 2 times 3 is 6. Double it, you get 12. You're always going to have that same sign right here. And then square the last so you get a 9. And that last term is always positive because you will, when you square something, it's always positive. Okay, now some other types of this is composition of functions. We're putting functions inside of functions. But you also can just have operations with functions. And I wanted to show you this notation. One way that example 6 could be written is it could be written as f of x plus g of x. But the worksheet that you're going to see today uses some of this notation where it just does f plus g of x. So when you see the plus sign in between, that means that you're just adding those two functions together. So for this one, that would mean you're doing 9 minus x plus g of x, which is x minus 1 squared plus 3. So we would have 9 minus x. We're going to have to square this out here. So Bronwyn, what would we get when we square that, the x minus 1 squared? Good. All right. Square the first. In the middle, you'll get a negative 1. Double it, you get 2. Square the last, you get a 1. And we'll still have this plus 3 over here on the end. So to combine all that, I'm running out of room. We'll have x squared. We'll have minus 3x. And then 9, 10, 13. example 7, we've got f of 3 minus h of 7. So we just have to find f of 3, which would be 9 minus 3, keep some parentheses around that, minus h of 7, which is going to be your absolute value of 7 plus 2. So 9 minus 3 is going to be 6. Absolute value of 7 plus 2 is just going to give you 9. 6 minus 9 is going to give you negative 3. All right, here. Okay, be really careful with these because you're going to possibly get these mixed up. This looks like f of g of 4, but it is not because that is a colored in circle right there, which means we're multiplying. So what this means is f of 4 times g of 4. So you're multiplying those together. When you have the open circle, it is composition of functions. It's f of g of 4. Whenever you have that closed, like that solid circle there, it's going to be multiplying. So you would just find f of 4, which would be 9 minus 4. And then you're multiplying this by g of 4. So you would have 4 minus 1 squared plus 3. So 9 minus 4 is going to give you 5. And then here, you're going to get 3 squared plus 3, which is going to be 9 plus 3, so we end up with 5 times 12, which will give us 60. And our last one that we have here is h over f of 6. So this just means h of 6 divided by f of 6. So our h of 6 would be the absolute value of 6 plus 2. Our f of 6 would be 9 minus 6. So we will end up with 8 over 3, which won't reduce, so you would just leave it like that. Questions? All right, so I'm going to pass out the worksheet for today, and I want to explain how to do it. I don't know if you guys have done these before. These are my favorites. There is a lady. Most of these that I use, I get from this lady that did this one, which is Virgil Corneliuson. She's pretty famous in the AP calculus world. She writes a lot of stuff there, but she does a lot of these types of worksheets, and they're my favorite to do because they check themselves without actually having to just give you the answers. Because sometimes whenever I just give answers, students may copy down the answers. Now, I have not started to suspect that you guys are doing that yet, but I have long ago quit giving answer keys to my Math 1 kids because lots of them may sometimes just copy down the answers without thinking of it at all. So the way that this is going to work, here is the very first problem is given to you right here. So we'll just work that one out together. It's pretty easy. You're just going to do 3. Some of these are going to be like easier than they should be for us, but some of them are exactly what we need to be working on. And no calculator on this. I did tell you to get your calculator today, but this is not calculator active. So make sure you square first. So you got 3 times 9 minus 12 minus 7. So that's going to be 27 minus 19. And so if we do 27 minus 19, we're going to get 8 as our answer. And so if we look down here, all of these give us the answers that we have. Sorry, that's moving with this. Right here you see the answer is 8. So that means that's the next problem that you're supposed to do. So you're going to put a number 2 right here because this is the second problem that we're doing. And then you're going to find g of negative 3. And whatever you get for your answer, let's say your answer is negative 56. I don't think it is. But if it were, then you'd go over here and do this problem, right? And so the idea, these are called a circuit. That is, if you do all the questions right, you're going to eventually do every problem on the page and end back up at the very first problem that you started at. So it kind of checks itself as it goes, because if the answer you get's not there, then you did it wrong. If you if you go back to the first answer without doing all the problems, then you've done something wrong somewhere. So it kind of checks itself as it goes. Everybody got the idea on those? So there's one other thing I need to show you, and that is an extra credit project that I'm going to give you guys. So I've posted this on Canvas, and I have, let's see, did I set the due date on this? Due date for this is going, I think I just put something in. It is going to be Wednesday. Oh, wait, hold on. What's the date? Today's 14th. Wednesday next week, so the 23rd. And let's make that, well, I'll just leave it 11:59, that'll be fine. Okay, so, this is sort of a very broad project. Some of you guys are finishing my work super fast, and I think we just need like a little extra enrichment to do here. Plus, some of you might just want to do this to bring your grade up a little bit because it can help if you've got a low test grade. It's a really basic project, what you're going to do. Your task is to create a picture of something in Desmos, and you will get the following points for the types of functions that you use. So basic functions I have classified as lines and circles, right? Their equations are pretty easy to do. So this could be vertical, horizontal, or slanted lines, circles. You get 0.1 point for every one of those that you use. You get 0.2 points for any intermediate functions. I've classified those as being polynomial functions, which is basically like x squared, cubed, 4th power, 5th power, 6th power, whatever you want to do there. It could be something like x to the 5th minus 7x plus 4x plus 3, something like that. So polynomial functions, square root functions, absolute value functions, and ellipses. I put those here in what I decided I thought was intermediate. Advanced, I'm going to count as trig functions. We haven't done trig functions yet, but they were in Math 3. So this could be any trig function, sine, cosine, tangent, secant, cosecant, cotangent. Hyperbolas, logs, exponentials, and rationals all fall into this category. So the more you use of the more advanced, they count more. But lines, lines are a lot easier, and you can put lots of them on there. You will get 5 bonus points if you use one of each of these types. Polynomial functions, it could just be one of them. It doesn't have to be x squared, x cubed, and x to the 4th, although you can use more than one if you would like. But so you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 different types. So if you have all 11 of these types of functions in your picture, that automatically gets you 5 points. So I guess if you wanted to go bare minimum to get the 5 points, you could have 11 different functions. It could, it add up these points plus you get the extra bonus 5 points on top of that. Point 4, if you want, it's beyond advanced. So if you want to like learn about a new function and use it in your picture, you can. Just to give you like an idea of what I'm talking about there. If you do x squared plus 3x minus 4x to the third plus y. All right, hold on. Let me make that y to the third. Y to the third equals 10. There's just a crazy looking function. All right, just kind of making up crazy stuff. You'll probably have to have x squareds and y squareds. Or not x squareds and y squareds. That's going to give you conic sections. Maybe like y to the thirds and cool stuff there. I think just kind of play with it and see what happens. It makes all kinds of crazy shapes there. Change some numbers. Maybe make that positive. It does all kinds of crazy stuff. The picture can be of anything that you want. It could be words. It can be, anything. There are a lot of these. Desmos actually has a competition with this where people like create stuff like this in Desmos. Here's a cat. We should be able to do pretty easily. Look at Shrek. That is so good. I will be checking to make sure that your pictures have not just been copied and pasted from the internet, because obviously you can find a lot of these pretty easily. So please make sure you're doing something original. If you come in with these birds right here, the first thing I'm going to do is go check to see that you have not just copied and pasted that. If you did your own name, I'm going to know pretty well that you didn't copy and paste that. So these are all, it's really just like a really loose sort of project. It's not anything fancy, but it's really, really good for your ability to know about how to shift functions up, down, left, right, because it gets them where you want them. So like if you think, well, I need to use a cubic, so y equals x to the third. Well, that's not where I want it. Maybe I want to move it to the right too. Oh, that's better, The other thing, I'm not sure how much you guys have used Desmos, but on Desmos you can restrict your domains. So if you do squiggly brackets, and do like -2 less than x less than 5. Let me zoom out a little so you can see that did actually restrict. So it was only that piece of the graph. Let me just make it a smaller number so it shows up. Let's do 1 less than x less than 3. So if you just wanted this little squiggle piece right here, you could do that. You can also restrict the range. Like for this particular case, you probably wouldn't want to do that. But let's say we had a circle. X plus 2 squared plus y squared equals 16. So if we had this circle. Let's say that we don't want to use all of the circle, maybe. Maybe we want to not use this top part or the bottom part. You could restrict your domain, or you can restrict your range. So you could do I only want to use from -3 less than y less than 3. So you can restrict your range. So it's cutting off here where it doesn't go above -3 or below -3 here. So you could use only a piece. This would make some good parentheses if you for some reason needed some parentheses in your problem. All right. So this will still count as a circle even if you restrict it so it's not using the whole circle in that case, because your equation was a circle to start with. to just give you an idea of some stuff that you can do there. Okay. I didn't put this on here, but I'm going to add it. Let me go ahead and add it right now. I'm also going to give you one more thing that you can get bonus points for. One bonus point for connecting two functions so that they are continuous. So that would look like this. Spell continuous correctly. I think it just doesn't like the fact that I put an S on the end of rationals right there. Alright, so, like let's say I just had a line y equals 2x minus 3, and I was pretty much, for pictures, most things you're going to want to restrict the domain so that you have just pieces of graph. So like let's say I'm using this from 0 to 2. Alright, because you don't want the whole line forever, you just want that whole piece of a line. So I've got this graph. So let's say I want to connect a quadratic to it right here. Maybe an upside down quadratic. It's going to make this upside down shape right here. So y equals, I need a quadratic. It needs to be upside down, which is going to be negative x squared. And I need to move that over here, right, so that I'm taking a point and I need to move it over. So like a good thing to do here is to get a point. Let me go back. Where's the house button? I don't have a house button. But a good thing to do, like, let's zoom in a little bit. So let's zoom out a little bit, actually. So like this point right here, let's say that's the point that I want to end up touching this right here. Well, that point needs to go up 5 and to the right 4. So to go to the right 4, I don't need those parentheses. I would need to put a minus 4 right here, and then I would need to go up 5, and so now they touch right where I want them to touch, right? And so I could restrict this domain from 2 less than or equal to x less than 6 or something here. And then there's my piece of that graph there. So you'll get a bonus point for connecting two functions seamlessly there. And they have to be completely continuous. We're going to do some piecewise functions. We'll do some more with that. That gives you an idea of where you're going. The maximum, these points will be added to your lowest test grade. I am putting a maximum score of 15 points on this because I do not want you to, make I'm not going to add 100 points if you do a really crazy picture. Now, I would still be impressed with really crazy pictures if you just want to do it for fun. And you really, honestly, to get 15, you're going to have to use a lot of functions there. Or the bonus points will help you if you use all of the functions. And the bonus point for connecting two functions so that they are continuous, that's a one-time bonus there. So you can't do that because you could rack up the bonus points too fast that way also. So that's a one-time thing there. All right, so questions about this? So this is something good for you to work on if you finish up, homework early or anything like that. It will be due next Wednesday. We're going to have our test on this next Tuesday, so it'll be due at the end of, right after the end of this unit. Okay. All right.